Hello, and hello, and welcome here to our late-breaking news about Log4j. Broke sort of late on Thursday. Of course, we did spend a lot of our time on the weekend to look and work on this. We're lucky to have Boyan and Mick here with us, and I don't want to introduce them too much. I don't want to waste too much time here just with introductions to tell us what we learned over the weekend, spending a lot of time here in front of the keyboard, trying to see what's going on. So, Boyan, why don't you take it away here with your section, talking a little about attacking this vulnerability.
Right. Thanks, Johannes. So I believe this was a crazy weekend for everyone in the IT security. So today we'll go quickly through the vulnerability that got released last week. I'll go through some technical details about how it works and how it's currently being exploited. And then we'll talk about some defense mechanisms and about some other potentially interesting things with this vulnerability. So every single security feed for last couple of days really burned with information about the Log4j vulnerability. It was originally reported by a researcher from Alibaba, and later it was assigned the CVE 2021-44228, as you can see, a number that probably a lot of us will remember for quite a while. And what's interesting is that originally the proof of concept exploit was published on GitHub sometime on December the 9th. That was Thursday last week. And we in the SANS Internet Storm Center started seeing first attack attempts very, very shortly after that. And in the last couple of days, a lot of other companies, including Cloudflare, reported that first attacks were actually seen some time ago on December 1st as well. So apparently this was potentially exploited even before the original proof of concept was released. So let's take a look at what this vulnerability is about and how it's actually being exploited in the world currently. So the vulnerability was introduced originally in the version 2.0 beta 9 of the Log4j library, which is a very, very popular library used by Java developers for logging. Now, there are two versions of this library, version 1 and version 2. And version 1 is, according to information that we have so far, not vulnerable to this vulnerability. There is another vulnerability in version 1, which hopefully isn't as critical as this one. We'll talk about this a little bit later. But the one that we are all concerned about is the vulnerability in Log4j version 2. And as you can see here in the release notes in item 313, in version 2.0 beta 9 was when new plugin, JNDI lookup plugin, was actually added. And this is the source of all problems that we will be talking about. So what did I actually add? This particular plugin was a lookup plugin, actually is a lookup plugin, that allows a developer to enrich the data that is being logged by the Log4j library. There are many lookups that Log4j2 supports, and some of them were actually there from some time before as well. Some simple lookups, and as probably every software in the world is being developed these days, the developers of log4j library also added quite a bit of new lookups here. So today we even have lookups for Docker and Kubernetes and similar mechanisms. Now the issue here is in a very specific lookup called the JNDI lookup, which stands for Java Naming and Directory Interface, which is a mechanism, an API that allows Java programs to actually perform lookups to objects. And this particular API supports a number of other protocols. This includes LDAP, includes RMI, which is remote method invocation, DNS, CORBA, a lot of other mechanisms, which will actually be the source of this particular problem. So when we look at this vulnerability, it is really an input validation vulnerability. In this particular case, the vulnerability exists in the log4j code, which will parse any input that is being received by users through any channel that this particular library can receive input from. In other words, and this is something that we will stress out later, even though most of the attacks that we are seeing today affect web applications, any lookup that ends up in a vulnerable log4j library can potentially be used as an exploit. The vulnerability itself is very similar to format string vulnerabilities in C. So what the issue here is about is that the log4j library will treat input actually as some kind of a format string. So it will literally look for a lookup in input, which will start with characters $, curly brace, JNDY, and then after colon, we can specify the protocol that will be used. So this is the lookup string that the library will try to parse, and after it successfully parses such lookup string, it will perform a lookup action in order to enrich the data that is being logged into this particular log. Now, the problem here is that remote code execution, when using JNDI and LDAP, is actually a well-known attack. 6 years ago at Black Hat, two researchers published several ways on how we can exploit such lookups. And basically, it boils down to the fact that LDAP as such allows us to store Java objects that are serialized into LDAP, which is kind of, I don't know, maybe crazy, but something that some applications can use. Or if those objects are too big, then we can use so-called references that allow us to put those objects even on different servers. And what's so scary about this is that when a Java application actually tries to fetch such an LDAP object, if it sees that there is an object that it needs to execute in order to successfully populate data, it will happily execute that code. And this leads to remote code execution, where exploitation is actually quite easy, thanks to work by these two researchers 6 years ago, and the exploitation mechanisms are actually already known. So let's take a look at how this works and how it's actually exploited these days. So in order to exploit this, an attacker must somehow submit a lookup that will point to their server. You can see two examples here. One uses LDAP, the other one uses RMI, which is remote method invocation. In both of these cases, when the vulnerable application, the application that is using a vulnerable log4j library, when it encounters this string, and this string can be surrounded by anything else, it doesn't matter what it's surrounded by, when the affected library sees this string, it will parse it, and in the first case, it will try to contact an LDAP server running on attacker.com on TCP port 1234, and it will try to fetch an object that will tell it how to actually resolve it. So on the right side of this slide, you can see the LDAP query that is being sent in this particular case. This was actually parsed with Wireshark, and this was real traffic from the network from one of the exploits. Now, when this LDAP request is received by the attacker, they can do two things. They can actually serve a Java serialized object back immediately, which is what some of the new exploits are doing, or what the original exploits that we saw on Friday started doing, is to serve a reference back to the vulnerable library, which will then go to an arbitrary server, fetch an object and execute it. So again, on the right side here, you can see the LDAP response that was again parsed by Wireshark. And somewhere in between that code, you can see an attribute which is called Java code base, which just contains a URL to the target object that will be fetched by the vulnerable library and executed. Very similar exploitation path is used for RMI, but almost every single exploit that we are seeing today uses LDAP. Keep in mind that also an attacker can use host names here, in which case the resolver will automatically try to resolve those DNS names, and this can be used for exfiltration of very, very sensitive data. So for example, we can embed any environment variables from the target server, from the affected server, into the host name, and this will end up leaking that variable to the attacker as long as the attacker controls the DNS zone that was used in the attack. This was actually used in a lot of initial exploits where people were monitoring DNS requests and based their conclusion on whether the target environment is affected or not just on DNS requests. Just keep in mind that in some cases it is possible that some other devices that are sitting between your browser and the target application performed this DNS request, so be careful about false positives here. So what attack vectors do we have here? Basically, anything that a user supplies, and I really mean anything, that gets parsed by log4j is a potential input vector. So currently what we are seeing is that there are some quite opportunistic scanners, bots that are just blindly attacking web pages and sending these exploit strings in various request headers. You can see one example here where the attacker embedded the exploitation string into the user agent header, X forwarded for, refer, and so on and so on. This is actually what our scanners, commercial scanners, do these days as well. But one thing that we have to keep in mind here is that this will only help with low-hanging fruit. If you have a web application which is protected with a login form, any parameter that maybe later is used by the application that gets parsed by log4j is a potential input vector. So just keep in mind that if you scanned your network and if you didn't find any vulnerable applications, doesn't mean that you are completely safe. Doesn't mean that you are vulnerable either, but just keep in mind that currently remote checks are quite limited. Both client and server applications are vulnerable. This was the example with Minecraft. If you have a client application that contains a vulnerable log4j library and a malicious server somehow sends data to that client library, we can actually exploit the client as well, which means that it will probably take a lot of time to fix all of these vulnerabilities, unfortunately. So finally, before we dive into some defense mechanisms that we might have, let's see what are the requirements in order for an attacker to exploit this. So first of all, they must be able to somehow deliver their input that will be processed by a vulnerable log4j library. And at this point in time, this is log4j 2.0 beta 9 all the way up to 2.14. Version 2.15 has been patched and it is not vulnerable anymore. The majority of current exploits require that the server on which the affected application is running connects back to the attacker's server or any other server that is under the attacker's control. This is needed in order for the attacker to push back that object, the serialized object that will be executed by the vulnerable Java code. This is a very good defense mechanism that Mick will talk about in a few minutes. If you prevent your servers from connecting to the internet, you can limit the exposure of your server. Keep in mind that this is not silver bullet, right? There could be other ways in order to exploit this. As you can see here, for example, if you're running on Apache Tomcat or WebSphere, there could be ways to exploit this vulnerability without having the server running the vulnerable application connect back to the attacker. But we haven't seen any such exploits in the wild yet. Finally, depending on the Java version, some attacks will be a little bit more difficult. Just half an hour ago on Twitter, a researcher published that they managed to successfully evade this, and their exploit is running with every Java version. So this will not be a proper way to prevent the vulnerability from being exploited. So with this being said, I'll hand over to Mick to talk a little bit about how we can defend from this horrible vulnerability. Off to you, Mick.
All right, so before we dive into the defense, the one thing that I need to impress upon you all is that you should not despair. You can mount an effective defense. Now, next slide, please. The number one most important thing that you should be doing is patching vulnerable systems. As of right now, there are no credible indicators that a patch applied will cause any production outages. The functionality that is needed for the attacker is so edge case that we don't expect any business logic to break. However, right, in the interest of testing, you do, or in the interest of fairness, you do want to test in a non-production environment first. That said, of the clients that I've been working with and the researchers that I've been collaborating with, I have not yet heard anyone say that applying the patch causes breaks. In fact, and this is something that some people are advocating, I don't know if I can recommend this, this function is so little used that many people are actually deleting the class file and basically removing the vulnerable code without applying the official patch. Now, you know, it's up to you whether you want to do that or not, but that does show just how relatively underutilized this component is. The other thing, for a variety of reasons, maybe you're in a holiday change freeze or you're not allowed to patch for whatever reason. Maybe you're only allowed to patch during certain mandated windows and there's no exceptions. Do not panic. In many ways, this is a fairly brittle attack. There's several moments of opportunity that you can seize upon that will make the attack just not work. One of the most important takeaways when you were being briefed how this attack works is the fact that the attacker needs to confuse the log4j function calls and make a request to a server that it normally doesn't. And so really, all you need to do, in air quotes, all you need to do is apply proper firewall rules on your application servers such that they're only allowed to talk to the servers that they're allowed to talk to. Now, that doesn't completely remove all of the risk, but it makes the level of effort for the attacker so dramatically hard that you're going to be relatively safe. And over the weekend, I shared via Twitter the IMA model. And if you could go to the next slide, please. So IMA is a technique for rapidly improving your security posture. And for the Log4j attack, IMA actually works quite well. What you can do is isolate your system through firewalls or even host-based firewalls. Minimize, meaning make it so that that application is running with the least privileges. You should be doing that anyway, but making it so that when the attackers are able to weaponize your environment, they don't have the keys to the kingdom. Instead, they're running in a constrained account. Also, virtualization is huge. Being able to rapidly revert to a known good state is amazing. Monitoring, I can't say enough that this attack, at least many of the techniques that we're seeing the attackers do in a post-exploitation phase are very, very noisy. We'll cover monitoring techniques in the next slide. And then if you haven't done active defense up until now, now is an exceedingly good time to start considering doing it. That said, you shouldn't start with active defense. It's a little more glamorous and people want to jump to it right away. Active defense should be done after you take care of the basics. The number one basic you need to do is patch if you can. If you can't, very tightly control your firewall configuration. Next slide, please. So some hope here. Indicators of attack. The attackers, no matter how skilled they are going to be leaving a footprint. On the hosts and devices, The main thing that you can key in on is CPU spikes. We're seeing a lot of opportunistic attackers who are deploying coin miners. And so seeing a CPU spike on a machine might be of interest and could be an indicator that you just got unlucky. Now, one thing worth pointing out is many organizations to date have been focusing their efforts on servers, and that's great. But as you hopefully are aware, Java runs on tons of devices. And according to Oracle, Java's on over 3 billion devices globally. So you're going to have to look beyond just traditional servers. This includes things like IoT devices and other small network gear. So you're going to have to approach this from multiple angles. Now, probably the best detect on a host is for a unauthorized configuration change. I'm not a fan of config management. It's boring, it's tedious, but this is why we do config management, because if you see unauthorized changes, if you see changes happening that are outside of change windows, you're going to want to triage this. And we're seeing that a lot of the attackers are relatively lower skilled, actually, and they're doing very noisy changes to systems. They're degrading the security posture on these systems. They're changing like the host firewall rules. They're doing things that the tradecraft is actually quite poor. Take advantage of that. From the network layer, this is one of the most observable attacks in quite some time, if you know what to look for. The most important things that you should be keying in on are your app servers, the systems that are running the Node4j. You should be keying in on unexpected network connections. Computers are very boring in who they talk to. It's a very deterministic thing. And if all of a sudden Bob from accounting starts talking to the research server, like, why? Bob, what's up with that? It might not be Bob. It might be this attack going on. The other item that I have been involved in a couple cases where these attacks were used in much more of a smash and grab style, where the attacker was able to gain a toehold into a network and started exfiltrating large bits of data out. We're seeing this mostly in cloud environments where they're pulling metadata information about how the cloud environment is set up and then using it to pivot and extract information. And you saw an example of how you can do using the environment keys, like environment variables, pull down things like AWS keys. And so you should be on the lookout for spikes in data volume. These systems that are running this code are almost always receivers of data. They are not pushing big amounts of data. So if you start seeing systems pushing amounts of data, that is something that you absolutely should be catching. I also want to give a shout out to Active Countermeasures for their free and open source tool, Rita. Use it. You can feed it both Zeek logs and NetFlow logs, and it will detect beacons. We have been seeing a couple instances of attackers who are setting this up for persistent access, and they're setting up beacons. So you should be monitoring for those. Now, I don't care how you start your defense detections. Some orgs are more keyed up for host analysis. Some are more keyed up for network analysis. Do what's ever easiest for you. Start with the easy. You will be shocked at how much you see. The attackers right now aren't being very sophisticated because they don't have to be, which gives us the advantage in that they are being far more noisy. So use that. Next slide, please. Oh. We're done.
So that was it. Now, can you switch to my screen, please? I just want to show quickly here a couple of the current attacks that we're seeing against this vulnerability, against our honeypots. So on the Internet Storm Center, we have a couple hundred honeypots sort of around the world. And we actually provide a fairly simple API here where you can just request basically all the requests that our honeypots are receiving that include like that string JNDI. Now, you can do this by URL or by user agent. People asked about the slides being posted. They will be posted later. I'll include those URLs in those slides, so you don't have to write them down now. I didn't want to make them clickable right now because I don't want to have 1,000 people click on it exactly the same time, which is why I also have them saved into a file, so I can show you a little bit from a file here what this looks like with the data that you're getting back from this. And I should have remembered my file name. So this is basically just filtered by URL. And what you get is, of course, here the classic URL string for it. Quite often now, and this sort of started yesterday, like I think Bojan mentioned this, they sort of just send it in multiple fields. So they send a user agent, send a URL and such. That's sort of very typical. You do see some attacks that are trying to exploit the DNS variants. So we definitely see quite a bit of those attacks. And then let me just pull out some of the sort of unique URLs that we are seeing here. The other thing we started seeing kind of today is where they sort of use some query parameters with it. That's, of course, now a little bit sort of one level up, where the entire URL may not be logged, but just query parameters. And of course, that's sort of another variation of the particular exploit we are seeing. Now, there's also a lot with these base64 encoded commands coming across. Heard different reports whether or not it actually works or doesn't work. So back to Mick's comment here, also don't panic. Not every exploit that you're seeing being thrown at your network will cause havoc. Now, saying that, there was just a couple hours ago, I think it was a British private cloud provider reported that their ransomware using this vulnerability, and their systems are down as a result. Pretty much this string, we very much focus here on HTTP as a delivering mechanism. But if this comes in as an email subject and is being logged, definitely could potentially work. Earlier, someone in the chat I saw made, I guess, a little bit of joking comment that, hey, don't use a username, the exploit string in this. If it's being logged by log4j, yes, it may trigger the vulnerability. That's really sort of a little bit the tricky part here. So these are URLs. Let's take a quick look at the same for the different user agents. Make sure I get my query right here. But yes, same thing you saw in the URL. The other part you're seeing here is this, I wouldn't call it obfuscation with the environment variables, or here actually not environment variables, but just basically lower command. The reason attackers, or here in this case, actually researchers are doing this to not get the false positives that Bojan talked about. So if they can distinguish that this host name that they're sort of sending here is being looked up versus the parsed host name after it went through log4j is being picked up. So that's another variation that you see it. And you see, of course, some people are using services like Canary Token and such to help them with their DNS lookups. In order to find out that you're vulnerable, you just have to be able to receive these DNS lookups. So any domain that you own works. Just set up a single DNS server for that, so it's easy to look at all the query logs, and that way, you can easily figure out if you're vulnerable. You could theoretically, not sure if it's a good idea, but I kind of like it. I'm living on the edge sometimes. Set up like an environment variable or something like this on your system, and see if that environment variable then shows up in DNS logs. That would sort of detect accidental exploitation of the vulnerability. Mick also mentioned environment variables. We've seen an awful lot of attacks where they're trying to get environment variables because so many people put their credentials, like API keys, AWS credentials, in environment variables. Try to find a little bit better way to store your credentials. But yes, it is often the standard way how it's being stored. And this is just yet another avenue how an attacker gets access to them. But I don't want to waste too much time. Like I said, the URLs are available. They will be included in the comments to the slides. This will actually be archived on YouTube. So maybe I'll just add a YouTube comment with the URLs. Also, the PDF or the PowerPoint will make available as well. So you should find the URLs there as well. But anyway, let's take a look at questions that we got. We want to leave a little bit of time for that. One question I see coming up is, and not sure if one of you can comment on this, is IoT devices. How worried do we have to be about IoT devices that are Java-based? Like these 4 billion Java devices. Are they all vulnerable? Or Mick, do you want to take that?
So unfortunately, you do have to be worried. The problem with IoT devices is that they're so pared down that they don't have a lot of the security components that we have. One of the other SANS instructors, Ron Hammond, has a great joke about this. IoT, the S stands for security. So the issue is when it comes to these sorts of IoT devices, if it's Java-based, most of the clients that I'm doing are doing better firewall isolation and find out from your vendor if they are going to be having patches. If you're in an ICS or healthcare environment, you should already be in a segregated or segmented LAN to protect those systems. If those devices are not segmented, segment them now and fast. Another thing that I wanted to mention, slight pivot, is that many times these attackers, what we're seeing them do is spray these attack techniques into any input, knowing that the system might not be vulnerable and waiting for a downstream reader or a downstream parser that's vulnerable to read it. And this bit's important. Just because it's not internet facing doesn't mean that it can't be exploited. There are cases of where the attack code was submitted on a public web page and that code was analyzed by an internal group and it activated inside the corporate environment.
And Boyan, there are some questions about the versions that are vulnerable. So Log4j 1 versus 2. And then also, I guess there's 2.15 that was originally released. Now there's 2.16. What should you patch for?
So version 1 is not vulnerable to this vulnerability. Actually, the author of the library confirmed that they treat strings as strings, which prevents Java from executing any objects there. And this actually saved a lot of applications that I checked over the weekend that I suspected could be vulnerable, but I noticed that the authors never bothered updating the Log4j library. They still had the old version 1, which went end of life in 2015. But when you have such a simple library, maybe you don't need to change it, and that actually saved them. So only version 2 is vulnerable, and this includes version from 2.0 beta 9 all the way to 2.14, including 2.14. 2.15 is the version that fixed the vulnerability. So if you're running any of these, then you are potentially vulnerable. Now, there was also a question, let me just answer that as well, about some scanners. Again, as I said earlier in the broadcast, remote scanning is quite difficult because it relies on the fact that you will end up supplying this malicious input into a parameter that is at the end being processed by the Log4j library. If you don't do that, you don't stand a chance on identifying this vulnerability. So it's not simple to identify it remotely. However, locally, and there have been quite a bit of scanners that have already been released that can locally check for the vulnerable library. And that is the way that you should take. That's how we should try to identify this vulnerability, to perform some kind of a local scan on our Java servers to check if there are any jars that contain the vulnerable library version. Also keep in mind that there is like a dependency hell here, meaning that you might not see that library just as a plain file. It could be bundled into another module. So you need to thoroughly check locally if this vulnerable library exists there.
And I guess it also depends on how the string is being logged. Like, thinking if it's applied on the URL, as we have seen here, as a parameter, it's often URL encoded.
Exactly.
If you don't decode the string before you log it, if you just log the URL encoded string, it's probably not going to trigger. Right?
Yep, exactly. I've seen such cases where strings were logged as URL encoded, and that this means nothing to Log4j library. So these particular cases were safe.
Yeah. And I just see a question again, HTTP, HTTPS. No, that's not the only way how it can be triggered. Whatever way you can expose, like, does Minecraft use HTTP, HTTPS? I'm not a Minecraft player. Maybe they
Me
do,
neither.
but they probably do. It's probably HTTP, HTTPS for them. And yeah, it was. There was also some comments I've seen about that vulnerability allegedly being exploited like 6 months ago or so. I guess there's a YouTube video. Be aware there have been earlier Log4j vulnerabilities. This is not the first one. Actually, if you're looking at the Oracle critical patch updates each quarter, there's usually a handful of Log4j vulnerabilities that they're covering in their products here. And
yeah. Exactly. So maybe just to add a couple of things. So regarding the protocol, it doesn't really matter which protocol you are using. Some of you probably saw that Ghidra, the very popular reverse engineering tool, was also vulnerable. And it was vulnerable just by loading a file that contains something like this, which ends up being processed by the log4j library. So the protocol doesn't really matter. It can be absolutely anything, as long as the attacker has a possibility of sending input to the target vulnerable application. There was also a question about some vulnerability management tools. I noticed that these popular vendors today actually started adding local checks as well. So by all means, if you can use those local checks, perform authenticated scans, because this is what will give you the best overview of whether you are vulnerable or not.
Mick, did you see anything about detection? Like you mentioned a little bit, network detection, any snort rules or Kata rules, Seek, any tools like that have sort of released something there? I think I saw some Suricata from emerging threats, but not sure for anything else.
Yeah, so Suricata has some interesting ones. One thing that you can do that I've seen that was pretty interesting is that some Zeek users, what they did is on suspected machines, they built a list of all the IPs that a machine was talking to based off of the con log. And then after the exploits became more available, they checked and see, are these servers talking to new hosts? And so that's a dynamite detect to see if an attacker is pivoting using this.
I would think in the Seek DNS log, some of that will also stick out like a sore thumb.
Yep, if they're doing the DNS technique. Yep.
Yeah.
The con log, at least so far, seems to be the main detect, because you're going to have both the source and destination and the protocol, because remember, this can be any protocol. Many of the early scans were DNS, but it doesn't have to be just DNS.
Yeah. And I've also seen LDAP as well as LDAP-S being used. So then you may not even necessarily notice it's LDAP, because they tend to use all kinds of ports. So it's not, I guess, connection on odd ports would be another thing. Like one problem I see is for a lot of sort of distributed web applications and such, you often connect to so many APIs. An outbound connection, it used to be in a web server. If you have an outbound connection, it was a big red flag. Well, that's all web servers are doing these days, kind of. Yeah.
Well, about that though, I'll lightly push back on that, because the servers that you're making the callbacks to tend to be of a fairly limited set. So it's the different business partners and people that you're working with. So it's not that the machine is boring, but the servers that they talk to is a fairly repeatable list, and that should be a boring list. And any new hosts, that would be something that I wouldn't necessarily call the fire brigade out, but I would start investigating.
Yeah, and that should work. Like, even usually these IP addresses don't change too often, because of course I tried some allow listing in the past, for some of these applications, and static allow list didn't really work well, because everybody hosts their crap in the cloud these days, and then of course you don't know what the IP addresses are. So that'll help. There's actually also an interesting Seek script I like that may help here. Any outbound connections to IP addresses that did not get returned in a DNS response. So if someone connects to a host by IP address, that finds all kinds of other stuff as well. This is not just for this, but it may help here, because some of these DNS requests you may not necessarily see. So that's another idea that may help. Anybody has heard anything about Cisco products? I see a question here about vulnerabilities in Cisco.
So I think Cisco is still checking whether they are vulnerable. I saw that their are few products that Cisco already confirmed that are vulnerable. So they will probably need to be treated. And also maybe to draw everyone's attention, since there was a comment about that that I saw in the stream as well, about vCenter, which is vulnerable to this. So this is like a very crucial part of everyone's environment if you run VMware. So make sure that you either, again, isolate it properly, as it maybe should have had already. If not, VMware published a workaround. There is no patch yet, but there is a workaround that you can apply to prevent this from being exploited. It's actually very easy to exploit it, unfortunately, and it grants you root access on vCenter, which means that you have the keys to the kingdom after that.
And I've seen that exploit already in the wild, so that one is definitely being used as is. What I'm not sure, and maybe either one of you knows, do you have to actually expose the vCenter admin console, or is it something that could be triggered without exposing that?
Yeah, so you need to connect to the vCenter admin console.
Okay.
It's pre-authentication, so you don't need an account. You just need to be able to send a request.
So in that case, I would say don't worry, because there were so many vCenter vulnerabilities recently, it's probably already pwned.
Okay.
Like if you're exposing your vCenter admin console, you're probably done, kind of. Let's see what else do we have here. Script to check whether a system is vulnerable. We talked about some of the vulnerability scanners and such. They're, of course, adding this as it happens. Updating your operating system may not be sufficient because that library is included in all these products. So you probably, by now, I haven't checked yet, but there may be some Linux package and such with updated libraries. They may fix some of the problem, but definitely not all of it. Anybody else? Is anything interesting we should cover in the comments here?
There is a question about XDR solutions. Well, they can probably help detect suspicious things like your, I don't know, Apache Tomcat server executing command exe or shell or something. So to a certain extent, such solutions can help detect. Not sure about preventing, to be honest, but for detection, they could help. I would be really happy that if I could say log absolutely everything, but that's kind of difficult to say these days, right?
Log more, kind of.
Exactly.
That's always the answer to any kind of problem like this. Guess we have sort of a final word, or so I want to sort of cut this off at one because I know Mick and myself have to go back to class. Final word for everyone. This will be recorded, so it will be available on YouTube. Check our Twitters. It's sort of scrolling by there at the bottom for any respective URLs. Mick, Bojan, any final words?
Thanks for everyone for joining. And I know it's been a rough weekend for a lot of us. I presume for majority of people here, but it's not end of the world. It is a very bad vulnerability, but if we follow some of the steps that Mick mentioned, I think that we can kind of have this under control, which will give us a little bit more time to actually work on getting things more secure.
Yeah, the one bit of advice I would give you is we're now getting very quickly to a point where we know enough about this, and it's unfortunately very bad. And so we need to start adjusting our pace. This is a marathon, not a sprint. Do what you need to do to triage, especially for internet-facing things, but this is going to be a problem for probably at least a year solid, if not more. So, work hard, work fast, do diligent work, but this is going to be a long, long issue. And I hate to scare you, but in every instance that I've seen library functions like this get exploited, additional attention is given to these libraries and new exploits come out, sometimes just as devastating or lesser so. So be on the lookout. There's probably going to be some follow-ons, unfortunately.
Yeah, I would compare it to the OpenSL Heartbleed vulnerability. I think it was similar in scope. So that's keep your notes for what Mick's saying. There will be more of the same. So keep your notes where you found log4j now. You may have to patch them again in a couple of months. Well, thanks everyone for attending, and thanks for all the comments here. So recording will be available. Thanks, Mick. Thanks, Bojan, for pulling this together on such short notice.
Thanks, everyone.